Okay, let's dive right into this masterclass. We are talking about transforming your basic mechanics knowledge into absolute gold standard evaluations for the Cambridge Mathematics syllabus. Welcome to the Explainer. If you have ever looked at a mechanics problem, the ones involving resolving forces or calculating some complex resultant, and you just felt completely lost halfway through your working, trust me, you are in exactly the right place. Today, we're basically playing the role of the alchemist. We are going to take the raw, sometimes really messy base metals of your mathematical knowledge and refine them. We're going to turn them into the pristine, high-scoring, structured answers that Cambridge examiners are desperately looking for. And it doesn't matter where you are in your journey right now. Whether you're building your foundational skills in syllabus codes 0580, 0606, 4024, 4037, or 4040, or you're tackling those rigorous high-stakes environments of the 9231 or 9709 AS and A-level papers, the fundamental strategy remains identical. So, grab a pen, because we are going to deconstruct exactly how to lock in those elusive multi-stage method marks step by step.
I want you to look closely at this quote. This is directly from a senior Cambridge examiner, and it perfectly captures their exact mindset when they are grading your paper. They say, "The difference between a B and an A star in mathematics often comes down to how well you understand mechanics. Resolving forces, resultants." Now you might be wondering, why is that? Because getting top marks in mechanics isn't just about regurgitating math facts you memorized, and it's certainly not about just magically arriving at the correct final number. It is fundamentally about proving your analytical process. The examiner is literally telling us right here that top-performing candidates don't just calculate things. They exhibit a connected, conceptual understanding that is completely transferable to totally unfamiliar, complex contexts. If you want that A star, you can't just give them the answer. You have to show them the entire architecture of your thought process.
Here is our roadmap for today's explainer. We're taking you from the symptoms of a bad grade to the ultimate procedural cure. We'll cover the challenge, the strategy reveal, the transformation, an interactive workshop, and finally, the final system.
Let's kick things off with Section 1, the challenge, the tale of two candidates. We are going to look at the two absolute most dangerous traps you can fall into during an exam.
This right here brilliantly illustrates exactly what goes wrong in the exam hall every single year. On the left side of your screen, we have Alex. Now imagine Alex's exam paper for a second. It is completely overloaded. Alex just throws every single raw mathematics fact, every single formula, and a bunch of scattered equations onto the page, basically hoping the examiner will sift through the massive mess and somehow find the right answer. But what does the syllabus explicitly state? It states that the assessment framework prioritizes analytical depth over superficial breadth. Alex's page is incredibly broad, sure, but it has literally zero depth. There is no connected logic whatsoever. Then, on the right, we have Sam. Now, Sam is fighting the clock. Sam rushes the problem, completely misses the specific command word requirements, and totally neglects presentation. Sam might actually have the right mathematical intuition about resolving a force on an inclined plane, but because the formatting is just non-existent, no proper headings, incorrect terminology, missing clear annotations, the examiner literally cannot award the marks. Both of these students, despite probably studying really hard, are just bleeding marks because they lack a standardized sequence of systematic processing. They're providing the what, but they are utterly failing to provide the how and the why.
So, the absolutely crucial point we must address, and I really want you to think about this question for a second, is this. Why do students find multi-stage analysis and method marks so incredibly hard to secure? Well, it's because mechanics requires logical, structured reasoning, not just memory. When you are resolving forces to find a resultant, you are essentially building a bridge out of logic. If one pillar of that bridge is missing, like if you haven't explicitly stated your assumption or if you haven't clearly separated your horizontal and vertical components using established principles of systematic analysis, the entire structure collapses in the eyes of the examiner. The method mark is essentially the examiner's way of rewarding the blueprint of your bridge, even if you accidentally drop a brick and make a tiny calculation error at the very end.
All right, moving on to our second section, the strategy reveal, decoding command words and adjectives. It is time to uncover the exact framework that top-tier candidates use.
Take a look at this definition of the method mark strategy. These are marks awarded specifically for demonstrating a logical, structured process and systematic analysis, even if the final execution has minor errors. Think of this as your ultimate safety net, but here's the catch: you have to actively build it. The Cambridge Conceptual Framework for Mechanics draws heavily on evidence-based reasoning. This means every single time you write down an equation to resolve a force, you are essentially making a claim, and you need to back that claim up with a clear, sequential step. You need to show the examiner your data interpretation skills. You need to extract the relevant forces from the text or the diagram, interpret the geometric relationships between them, and literally draw an evidence-based conclusion right there on the paper. If your process is transparent, organized, and follows a standardized sequence, the examiner literally has no choice but to award you those highly coveted method marks.
And to structure that logic perfectly, we use the PEAL framework: point, evidence, explanation, and link. Now, before we break down exactly how to apply this to mechanics, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so while PEAL is often thought of as an essay writing tool, it is actually devastatingly effective in higher-order mathematics assessments. Let's break it down. Your point is identifying the key element or force you're dealing with. Your evidence is the specific data you've extracted from the complex mechanics diagram. Your explanation is applying the relevant mathematical principle, like using trigonometry for resolving vectors. And finally, your link is verifying the results and explicitly connecting it back to what the command word asked for. This is exactly how you guarantee your marks.
Let's dive into Section 3, the transformation, from flawed to flawless analysis. We are going to look at the exact procedural life cycle you must follow in the exam hall. Listen, this isn't just theory anymore. This is a highly specific minute-by-minute execution plan for a standard 5-mark mechanics question. Watch how the red pen marks of failure transform into the green check marks of success when you actually follow this exact sequence. Minute 1 is all about deconstructing the question. You do not write equations yet. You read the command words. Are you being asked to evaluate, compare, or calculate? Minute 2 is data extraction. You're pulling the relevant variables from the text and tables. You are identifying the exact magnitudes and directions of the forces involved. Minute 3 is where you select your analytical framework. Are you going to resolve forces horizontally and vertically, or does the scenario demand parallel and perpendicular to an inclined plane? Minute 4 is the critical execution phase. This is exactly where Alex and Sam failed, but you will succeed. You execute with crystal clear notation. You write out your workings systematically, showing every single step of your evidence-based reasoning. And finally, minute 5 is presentation. You verify the results, you check for reasonableness. Does a resultant force of 10,000 newtons make sense for a tiny toy car? Probably not. And you present the solution in the appropriate format with correct terminology. This timeline forces you to slow down, structure your logic, and hit every single assessment objective the examiner has on their grading rubric.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump straight into Section 4, our interactive workshop, Identifying Examiner Warnings. We've meticulously scanned the principal examiner reports, and we have the exact data on where candidates are failing the most. I need you to pay very close attention here, because these are the top 3 mistakes that will absolutely tank your grade in Cambridge mathematics. First up, confusing cause and effect in mechanics. Examiners report over and over that candidates constantly mix up the applied forces acting on an object with the resultant kinematic effect, like acceleration. You must clearly separate the forces causing the motion from the resultant of the motion itself. Second, forgetting to check format, correct terminology, and presentation. Remember what we said earlier? Presentation follows strict conventions. If you don't use proper headings, if your annotation on a force diagram is super sloppy, or if you just use the wrong units entirely, you are literally throwing away easy marks. The presentation of your information is a massive test of your procedural framework. Third, providing generic answers not specific to the question context. This is a massive examiner alert. Higher order assessment objectives absolutely demand that you evaluate the specifics of the scenario given. Rote memorized statements about resolving forces will get you absolutely nothing if you don't apply them uniquely to the specific object, the specific angle, and the specific friction coefficients provided in that exact problem.
This slide brilliantly illustrates that third point we just talked about. Let's look at a flawed versus a perfect approach. The flawed approach completely relies on generic, rote-memorized statements. A student might just write down F equals ma and start randomly plugging in numbers blindly without ever defining the system. It's a mess. But look at the perfect approach. It is a highly context-specific analysis. The top-tier student links every single resolved force directly to the given scenario.
Furthermore, for those who want those top A-star marks, the syllabus clearly highlights the need for comparative analysis. This means identifying similarities and differences, using comparative connectives, and actually supporting each comparison with hard mathematical evidence. If the question asks you to evaluate two different methods of pulling a heavy block up a ramp, you can't just calculate both and stop there. You must draw conclusions about their relative importance, justify your recommendations, and explicitly state why one analytical approach is superior based on the evidence you literally just calculated.
Okay, it is time for a 30-second speed challenge. I want you to look at the screen and visualize the deconstruct, solve, evaluate pipeline in your head. Imagine a complex data chart showing varying forces over time. Your brain should immediately break this into logical steps. First, you deconstruct. You identify the given information and the ultimate goal. Second, you solve systematically, applying your PEL framework to extract the core trend from the noise. Third, you evaluate. You check your calculated resultant force for real-world reasonableness. Would this force cause the object to instantly break? Is it realistic within the context of the physical model provided? This rapid-fire mental evaluation is exactly what separates the average candidate from the exceptional one. It proves to the examiner that you aren't just a calculator, you are a high-level analytical thinker.
Which brings us right into our final section, the final system, your ultimate mathematics success blueprint. Let's consolidate everything we've learned today into 3 absolute, non-negotiable rules.
So, the crucial point to remember is that this system works every single time you use it. Rule number 1, command word decoding. You literally do not touch your calculator until you know exactly what the question is demanding, whether it's descriptive, analytical, or evaluative. Rule number 2, PEL framework application. You structure your working sequentially, no exceptions. You state the principle, you show the extracted data, you perform the analysis with clear step-by-step working, and you link it right back to the context. Rule number 3, verification and format checking. You rigorously check your presentation. You ensure your headings, your notation, and your terminology are flawlessly aligned with Cambridge conventions, and you verify that your final answer actually makes logical sense in the physical world. If you follow this standardized sequence, you are practically immune to losing those precious method marks.
And you know what? The data backs this up entirely. See that massive number 2 on the screen? Students who implement these mathematics strategies see an average improvement of 2 full grade boundaries. That is the massive difference between a C and an A, or a B and an A star. But listen to me, this transformation does not happen by accident. It only happens if they practice consistently with our weekly videos, absorbing these examiner insights and relentlessly applying the procedural framework to real past papers. The data is crystal clear, shifting your focus from just frantically finding the right answer to showcasing a flawless analytical process can elevate your grade boundaries significantly. But here's the ultimate question you must ask yourself before walking into that exam hall. Are you just memorizing mechanics, or are you truly mastering the logic behind them? Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep analyzing, stay methodical, and we'll see you in the next explainer.